Hello, so in today's video, we're going to differentiate this function. So the natural logarithm of the modulus of sec of x. So we're going to differentiate this function today. So the key thing is that this function is defined, well, this derivative is going to be defined, and this function as well is going to be defined when this modulus of sec x is not equal to 0. But the sec x function is actually never equal to 0 anyway, so that's fine. We just got to check when this sec of x is defined for. So this sec of x is defined. So sec of x is defined for all values of x in the real numbers, but apart from these odd multiples of pi over 2. So 2k plus 1 times pi over 2, where k is just an integer. So k can't be, the x values cannot take these odd multiples of pi over 2. So for example, pi over 2, 3 pi over 2, negative pi over 2, and so on and so on and so on. These odd multiples of pi over 2, so we can't take those values. Otherwise, the sec function becomes undefined. But yeah, let's go ahead and differentiate this function by using the chain rule. So differentiating the ln of sec x, and if we do that, so this is just going to be the derivative of ln of sec x with respect to the modulus of sec x, and then multiply that by the derivative of the modulus of sec x with respect to x. So yeah, this is just an application of the chain rule. So we know that when we differentiate the natural logarithm of a variable with respect to that variable, we get 1 over that variable. So this first derivative is just going to be 1 over the modulus of sec x, and then we're going to multiply it by this derivative here. So we did this in a previous video. I'll just make a note here that this is using previous videos. So when we differentiate this modulus of sec x, we just get the modulus of sec x multiplied by tan of x. And so what happens is that this modulus of sec x cancels out. And because that cancels out, we're just left with tan of x as our derivative. So yeah, so what we can conclude then is that d by dx of the modulus of ln, the natural logarithm of the modulus of sec x, is just equal to tan of x, where x can be any real number. So where x is any real number apart from these odd multiples of pi over 2. So apart from these odd multiples of pi over 2, where the sec function and also the tan function is undefined, apart from these values, this will be this derivative, and this function inside there will be defined. So yeah, that is the answer for this derivative here.